Okay, so we said mean can be calculated by that is sum of all the values, okay, divide by the total count of what, of your values, of all values. Basically what I mean is, like, we'll have to now take x1 plus x2 plus plus x3 plus x4 plus x5, then divide by what, by the count. So the count will be 1 2 3 4 5. Okay, so the count, and we say that the count is n. Okay, all the sample size. Okay, so divide by n. So basically x bar will be what, will be equal to this. All right, we can even simplify it and say that is, let's assume these are xi's, they are xi's, okay, up to 5. So we can say it is summation, or that is x bar is equal to summation of xi's given I, it's ranging from what, from 1 up to n is equals what, is equals to 5. Okay, then divide by what, divide by n. So basically this is the formula for what, for sample, that is for sample mean. Okay, yeah, so this is the formula for mean. When we come to Excel, we have an inbuilt function. Excel inbuilt function, we have an inbuilt function that is an inbuilt function, which is average into now the range, let's say range of what, of your data, average, okay, of the range of data. So we shall also check this when it comes to what, when it comes to Excel inbuilt function. Okay, all right, I guess we are good with the mean, right? Are we all good now with mean? Okay, awesome. Okay, good. Let's now go to the second part. So whatever I've explained, yes guys, so this is what I was trying to avoid. Okay, so you can see I'm taking much of my time admitting that is these people. So it's always good if we can use the Google, that is the calendar invite, which I had shared with you. Okay, let's continue. So we have average, then whatever we've discussed here, it's whatever I've illustrated. You can see mean is given by sum of all data values divided by the total number of that is of data values. Okay, all right, good. Let's go to median. Okay, I'm going to illustrate for median. So median, we said median, it's like it is the middle value of a sorted set of values. Okay, so let's assume we have 5, we have 4, we have 6, we have 7, we have 2, 3 and 1. How many values are this? 1 2 3 4 5 6 7. So we will check when, maybe we'll check like for example, when the count of the values, it's odd. Okay, which is our median. Okay, so median when the data values are what, are odd. Okay, so in this case, to find the median, we'll first of all sort this data either in ascending order or descending order. Okay, so in this case I can use ascending order, so it will be 1, 2, 3, 4, 5, 6, and 7. Okay, so our median will be the middle value in our data set. So we can say 1, 2, 3, 1, 2, 3. So our median or our middle value, it's what? It's 4. So in this case, our middle value is what? It's 4. Or our median, it's 4. Okay. Let's assume that is the count is what? The count is even. Let's assume the count is even. Okay, so if the count is even, okay, we can add a value here like 8 comma 8. Okay, so what will be our median if the count is even, like 1, 2, 3, 4, 5, 6, 7, 8? 8 is 8 in count, it's what? It's even. So in this case we are going to also that is sort this data. Okay, so I'm going to sort as 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so we need the middle value. So in this case I will go with 3, 3. So we can see we don't have a specific, okay, value which is in the middle. So in this case, we are going to what? We are going to that is to take these two middle values, okay, add them and divide by 2 to get the middle value, or to get the median. Let's say to get the median of what? To get the median of of our set of our data set. So in this case, the median will be 4 plus 5 divided by what? 2, which will be is it 4.5? It will be 4.5 because it is 9 divided by what? 9 divided by 2. That's all about median. All together under median, all together, team. Okay, I can see only three. Okay. Right. Good. So, okay. I hope we are all okay. I've seen less than 10 thumbs ups. So I hope the others are also okay. Yes, Joy Shimwenyi.
Yeah. Just a question. So, what happens if you have a really large data set and you're supposed to calculate these things?
Sorry.
What happens if your data set is large?
So basically, if you have a large data set, that means you cannot what? You cannot do it manually. Okay, you can start sorting out. Okay, let's assume you are given a data set with a million entry. You can't do it manually. That's why we have now an inbuilt Excel function which will do that work. Okay, it will do it will do that is the calculations at the back end. Okay, and give you what? And give you a result. Okay, so we will see that we have a function. We have a function known as median. So median, an inbuilt function known as median. So we have the median, then you are told to highlight what? The range. And once you do the range of your data set, you can now get your median. It will calculate itself. So this the function is programmed in a such that is in such a way it calculates or it runs all these calculations backend. Okay, that's okay. Joy.
Mm. Yes,
Yes.
thank you.
Yes, so we have inbuilt functions which always help us to ease our work. Okay, so I guess whatever I've explained here, or I have illustrated, it's whatever in what? In these notes. Like for example, median is the middle value of a sorted data set. Okay. Then the steps, you have to arrange the data either in increasing or decreasing order. Okay. If the data set has an odd number of data values, odd, then the middlemost value of the sorted data set is computed as mean. Okay. What about if the data set is what? It's even. Okay. So if the data set is even, okay, then the average, okay, the average of the two middle values is computed as what? As the median. Okay. Yes. So basically that's what I have that is shown you. Okay. Then let's go to mod. So for mod, you remember I guess for mod I illustrated very much that is very well. Okay, so let's talk about mod. Okay, let's assume we have this kind of data set. The first scenario, it will be that is 1, 6, 2, 3, 2, 7. Okay, that is the first illustration. Then the second illustration is 6 to 1 7 3 2. So in this case, you know our mod, we only have one mod. Okay, that is the most occurring, the most occurring what? Occurring value. Okay, so in this case, as you can see in the data, 1 is occurring once, 6 is occurring once, 2 is occurring twice, okay, 3 once, 7 once. So basically, our mod will be what? Will be 2. In this case, for this, we can term this as what? As a single mod. Single mod. Why? We only have one mod. Okay, let's go to the second scenario. So for the second scenario, you can see 1 is occurring twice, 6 once, 2 twice, 7 once, 3 once. Okay, so like we have 1 and 2, they are occurring more than what? More than once. So here our mod will be what? 1 and 2. Okay, what if maybe you are told now I need to get a single mod? Okay, please get a single mod, okay, out of what? Out of this data set. Okay, so if you go with a single mod, then the first occurring or the first value which is occurring more than once, okay, then that becomes what? Your mod. Okay, so in this case, one will be what? Our single mod in this second illustration. But if you are just asked mod, then you know it is what? 1 and what? 2. And in this case, this is called multiple mod. Okay? Multiple mod. Any question? Any question up to that point? Yes? Give Elizabeth.
I've not understood what we will do when you're asked to find just one single mode. I think I missed something or something.
In which illustration? The second
In the
illustration.
second illustration, the multiple, yeah. So if you're asked to get
The
to be
mod.
just yeah,
Only
just a
one mod.
single out of this, yes.
So you can see in our data which is the first value which is occurring more than once.
It's one and two.
But which is the first value which is occurring more than once?
Okay, one.
Correct. That will be your single mod.
Okay.
Yes. But now if you are asked about a multiple mod, then it will be 1 and 2. So if for example we had what? Let's assume we had 2 here instead, and we had what? 1 here. Then what would be your single mod here? It will be what? It will be 2 now, because 2 is the first the value which is what? In your data set. No arrangement here, remember. Okay? Yeah. So I guess that's clear. Okay. Kindly explain. I guess we are all together. Selling Wadera. I hope we are. Yeah. Nice. Okay. Good. Let's now continue. So, that is while or when doing our analysis, is always not advisable to use mean to make conclusions. Why is that? That's just a general question. When calculating or doing some analysis, it's always not advisable to make conclusions using a mean value only. Why is that? Someone? Why are we advised not to only use a mean to do what? To make decisions. Yes, Brian?
Outliers.
Yes, so mean is it's affected by outliers. Okay? Mean is highly affected by outliers. So we can't use mean, okay, to make conclusions. Okay? What are outliers? So outliers, they are extreme values. Okay? Majorly they are extreme. It can be extremely small or extremely what? Or extremely large value. Like for example, let's assume I'm working with weight. Okay, weight of what? Weight of 4 students. Okay, and okay, our students. Let me just generate those weights. So we have the first student is has a weight of 50.5. The second one has a weight of 50. The third one weight of 52, and the fourth one weight of what? Let's say weight of 51. Can someone maybe calculate the mean of this, or the mean weight of this? What will be the weight? That is the average weight. If you have a calculator around you, someone? Okay, we can do it then together. So we have 50 sorry, so it is 50.5 plus 50 plus 52 plus 51. Okay, then divide by what? Divide by 4. What will be our average? Have I divided by 4 or have just multiplied by 4? Anyway, let me use Excel so that I may show you um, a very quick way of calculating and also illustrating it. So we've said we have 50.5. Okay, we have, is it 52? We have also 50. Okay, and we also have 51. All right, so we need the mean. Let me just enlarge this. So we need the mean of this. So the mean will be what? The mean will be, that is the average, the symbol average. Okay, the average of this. So you can see this is the what? This is the average. Okay, that is 50.875. And if you can see this value, it's within what? It's within this range. Okay, it is within, that is the range of, that is between 52 and 50. Okay, what about if we had one of our student having a weight of what? Let's say 120 kgs. What will happen to the mean? So you can see the mean has shifted, okay, from 55, which we had initially, okay, to 50.875 to what? To 68. Why? Because we've injected an outlier, okay. So you can see now when we that is inject, that is a value which is a big value, then the mean will shift towards that is large value. Okay, like for example, we'll have what? We'll have a right shift towards that large value. Okay, if we go with an extremely small value, then the mean will adjust towards what? That small value. Okay, so like for example, if now I use, let's say, 5 grams, it's kilograms. Okay, you can see now the mean has adjusted towards what? Towards the, that is the that extreme value. Okay, so that's why we usually say mean is affected, what is majorly affected by outliers. I hope that point is well explained. Okay, all good. Okay, good. Let's continue now. We are done with, that is the measures of central tendency. Okay, so you can see now we have some examples. You can go through the examples. Okay, that is for mean. We have example okay, we can see this mean is highly impacted by extreme values in the data set. If the data set is symmetric, the mean value is located exactly at the center. However, if the data is skewed, then the mean will be pulled away from the what? From the center, either to the right or to the left of what? Of our, that is of our initial mean. Okay, all right. Then you will also calculate mean. We have measures of central tendency, just some closing remarks. So mean is preferred. That is, mean is the preferred measure of central tendency when data is what? Normally distributed. Okay, like we are having no skewness at all in our data. So median is the best measure of central tendency when now the data is skewed. Mean is the best. Okay, measure of central tendency. When the data is normally distributed, then mean is the also the best measure of central tendency. Okay. Then when dealing with nominal variables, then that is the mode of the data is what is the best measure of central tendency. Then we have some conclusions. Mean, median, and mode are the most important measures of central tendency. The complete data set may be represented by these values. Okay, it is not necessary for mean, median, mode to have the same values. Okay, then mean is very sensitive to extreme data values. It is not wise to take the mean of skewed distribution as the true representative of data set. Okay, then median is better way to understand skewed distribution. Then mean and median cannot be what? Zero. Mean and median cannot be what? Zero, unless all the values are what? Are zero. However, it is possible that there can be no mode in what? In a data set. But we cannot have zero mean or zero median. Okay? Unless maybe for zero mean when we are talking about standard normal distribution. Okay, there is a way we can standardize normal distribution, okay, to have our mean 0 and our standard deviation 1. Okay, all right, I've closed on the measures of central tendency. Let's go to the second measure, that is measures of variability. Now, here we are talking about variance. Okay, we are talking about variance and standard deviation. Yes, Jennifer?
Yes, sir. Good evening.
Yes, good evening.
I would like to ask a question. I don't know if maybe it's fundamental, but when we talk of measures of central tendency,
Uh-huh.
what do you normally mean when we talk of central tendency?
So central tendency, from even the term central, like measures of central tendency, they are showing us how our data, maybe it's what? It's distributed, okay? Like, is our data towards maybe a specific central point, okay? Or, but don't confuse with the measures of variability, because in fact for the measures of variability it's the one which is showing us that is dispersion, okay, like how the data is distributed away or close to the what, to the mean. But when we talk about central tendency, basically it's giving us like the key sender points, okay, of our data, like what we really need in our data. It's kind of descriptive statistics that gives us an overview, okay, or gives us maybe how our data is centered, okay. Is it what is the sender of our data set when we talk about what? That is the median, okay? And also averagely, what is our what? What is our data? That is what is the mean, all the average of our data. So basically from the term central, okay? Yes, unless maybe you have another maybe illustration or elaboration on the measures of central tendency.
Okay, thank you, sir.
Okay. Then don't now confuse about with the measures of variability, because here when we are talking about measures of variability, we are trying to check the distribution of our data. Is our data far away from, or our data points, are they close, that is close together, okay, or they are spread away from each other? And that's where now we will start with the variance. Okay, so maybe can someone explain or define variance. What do you understand by the term variance?
Excuse me.
Yes.
Just a little before you go to the variance.
Uh-huh.
From the example given,
Mm-hmm.
I see in the calculation or in the finding out of the mode in the first example.
Mm-hmm.
Yeah, let's compute mean, median, and mode. Now, mode is 36 kgs,
Mm-hmm.
and each of them is appearing once.
Okay.
Yeah, so why is that?
So maybe that can be a mistake. Maybe a typo. It can be a typo, that one.
So in
Maybe
this
it.
case, we have no mode.
Yes. Yes. In
Okay,
that case, we have no mod. Okay. More. That is. Yes. I guess it's a typo. Okay.
okay,
It's a typo.
it's okay. Thanks.
Yeah. Yeah. So maybe you can please change that. I guess it's a typo error. All right. Thank you for that. Thank you for that, Joseph. All right. What is variance? Question to you, class. What do you understand when I talk about variance? What is variance? Yes,
Let me
Freddy?
try that one.
Okay.
Yes, I think when we're talking about variance, we are looking at how spread the data is. So we'll go back to the examples that you gave, the 50.2, 50, was it up to 52.5?
Yeah.
Yeah, so you are looking at the least and the highest. So that sort of difference or the range or how spread the data is. So that's variance. And this is in contrast to what you've just given us about the central tendency, which in a layman's or a layperson's understanding deals with averages. Thank you.
Okay, maybe, of course, good point when you talk about spread. But what kind of spread? Is it the spread between the data points, or it is spread away from the mean? Okay, for the spread, that was I will take that home. Yes, someone else?
Now, I would say, okay, from the word variance itself, I think it's the difference between maybe the actual and what is maybe represented or the expected vis-a-vis the actual. But now, when it comes to statistics, I guess it should be the variance, the difference between what we have just found in the measures of central tendency, the mean. How far is a value from the mean? That's what I would say.
Okay, okay, right, yeah. I will take also that point for how a value, okay, is away from the mean. Yes, Titus.
For me, I would say
Hmm.
is a measure of how data points differ from the mean.
Yes, of course. Like how that is our data points are away from the what? Are away from the mean, or they are spread. The right term to use is how is our data set spread? Okay, away from the mean, or it is the distance between what? Our data points and our mean. So basically, like for example, if we were to illustrate maybe in layman's language, I don't know how mathematically, if it is mathematically correct. Let's assume we have our different data points and maybe the average point, okay, or the mean of our that is data point, it's in this point, okay. Then we try to plot other what? That is other data points, okay. We can now that is plot other data points. What we are trying to talk is the distance between each data point, okay, and the mean. The distance between each data point and the mean, okay. the difference might be a negative. That's why we usually square the what? We usually square the difference, okay, to make it that is an absolute value, okay. So the distance between the mean and each data point, it's what? It's that is it's our variance, okay. And remember, let me take another scenario. Let's assume our minutes here and our values are far away from the what? From the mean. So definitely the distance between each, or the sum of the distances between each data point and the mean will be what? Will be high, okay, in comparison to this second illustration, okay. So we might have a high variance and a low variance, okay. All right, so one thing, variance is always a positive value, so you cannot get a variance of negative. You cannot have a variance of negative, maybe let's say 60. It is wrong. That's why we usually take, like, for example, let's assume it is the variance of what? That is a sample size variance, okay. That is a sample data variance, which is s squared, is equals to, let's say it is the xi, okay, that is x1 minus x bar raised to what? Raised to 2, all right, plus, maybe let's assume we have an x, we have another x, okay. Let me just illustrate. So let's assume we have values x1, x2, x3, x4, and x5. This is a sample what? This is a sample data, okay, whereby n is equals to what? N is equals to n is our sample, is equals to our sample size, okay. So in this case, we know basically, or mathematically, we know that variance, which is sample variance, is always given by summation of that is i's, these are i's, okay. Let me use the correct term. So it is always summation of x i's, okay, minus x bar given I, taking values between what? Between 1 to what? To n, okay. Then you square the what? The difference here. Then if it is sample data, then you'll divide by what? N minus 1, okay. If it is a sample data, you will take now n minus what? N minus 1, okay. So in this case, let's try to express this, okay, in this format. So or to express this, I want to derive these values to get something like this, okay. All right, so in this case, let's start with what? With this. So if we want the mean of this data set, okay, definitely it will be what? X bar. So in this case, it will be x1 minus x bar, okay, squared, because remember the variance, it's the difference between the actual values and the mean, okay, squared, okay, to make it an absolute value. So plus x2, okay, minus x bar u square, plus x that is x3 minus x bar u square, you also square here, up to plus x5 minus x bar squared, okay. Then divide by what? By n minus 1 to make it what? We are saying that, or we are using n minus 1. Why? because it's a sample data. It's like, let me try to show you. Let's assume y, or you can just go and research. Let me give you that as a assignment. Why do we usually use n minus 1? I know I had talked about it yesterday, but go and check. Why do we usually use n minus 1 when we are dealing with what? With sample size or with sample data. But if we were using that is a population, it will be just a capital N only. Okay, you can go and research on that. Okay, yeah. So now trying to express this, of course we can express this into this. We can say it's equals to maybe 1 divided by n minus 1. Okay, then multiply by all this. Okay, here. So now you can see we are having, it's like we are having what? The sum of difference, okay, of these x values. Okay, so it's like saying 1 divided by n minus 1, okay, multiply by, we are summing all x i's, and we know I is taking a value of 1 to what? To 5. Okay, minus x bar, which is our mean. Then you do what? You square. So you'll get what? You'll get the same expression as we did here. Okay, yeah. So basically what I'm trying to say is that mean, that is variance, is the distance. It's trying to show us how far away is our data points from the mean. Okay, all right. So let's go maybe to the notes and see what the notes are saying. Someone has raised hand. Yes, Elizabeth.
Could you go back to that the calculations that we are doing?
Mm-hmm.
So yeah, so the variance, is the variance the s power 2, or is it this 1 over n? So this
So
one, this one.
this
Mhm,
variance is just a denote. It's like we are denoting. Okay. So this
mhm.
is s squared is the what? Is sample variance. This is just a denotion to if I see s squared, I know this is variance for what? For a sample data. And now if we are doing to do we are to calculate that, we would use this formula. Okay, it's like the same for population. If you see something like this, which is sigma squared, you will know that this is what? Population variance. Okay, then for standard deviation of sample, it will be s only. Okay, and then standard deviation for population, it will be sigma only. Okay, like the way we are also doing for mean, we know x bar is what? Is the sample mean. Okay, but mu is the what? Population mean. So these are just symbols to denote sample mean, population mean, sample variance, population variance, sample standard deviation, and population variance. But this is the formula.
So the 1 over n minus 1, the formula that comes before the summation.
It's the one I did here initially. You can see the one I also did here. Okay.
Mm-hmm.
Yes, I just tried
Okay,
to
okay.
factor everything out. You can see it's the same thing.
Oh,
It's like
okay,
saying
I
now
see.
this divide by n minus 1. Okay.
Okay. Mm.
All right. Any other question? Okay, good. let's go to variance and see what variance is. And also, before I can discuss about the variance, then let's assume you are asked to do what? To calculate now the standard deviation. So we know that standard deviation is always the square root of what? Of variance. Standard deviation is always the square root of variance. Okay, so in this case, our standard deviation will be a square root of 1 divided by n minus 1 summation of xi's minus x bar squared. So this is our standard deviation. Okay, let's go to notes. So what is variance? So the term variance refers to a statistical measurement, okay, of the spread between numbers in what? In a data set. Okay, so we are talking about the term variance, the statistical measurement of the spread. Now the spread, it's like the difference of the distance. Okay, the spread between the numbers is the values in a data set, okay, from the mean. More specifically, variance measures how far each number is, okay, in what? In a set of data is away from the what? Away from the mean, okay. Like variance measures how far each number in the set is from the mean, and that's for every other number in what? In the set. So basically it's trying to show us the distance between the what? The individual that is values and the what? And the mean. Okay, it's like when we'll be discussing about regression analysis. Okay, when we'll be discussing about regression that is analysis. Okay, we'll talk about something we call error term. Okay, okay, so like error term, it's like the wide deviations, like the distance of, there are some data points which definitely the line of best fit cannot go through. That is all the data points. Okay, so also the distance between what? Between the data points and the line of best fit, okay, tries to show us the performance of the model. Okay, if the distance is very high, then our model will do what? Will perform poorly. Why? Because our model will not be the best model, or it will not fit that is our data points well, okay, compared to when we have what? A small error term. Okay, but we shall discuss that when we get there. Okay, all right. So we are saying that variance is often that is depicted by this symbol, sigma squared. This is majorly for population variance. For sample variance, it is S squared. It is used by both analysts and traders to determine the volatility and what? The market security. Okay, so the square root of variance is the standard deviation, that is sigma, which helps determine the consistency of an investment's return over a period of time. So basically I can say variance tries to show to help us to determine maybe volatility of maybe let's say uh, some stock. Let's assume you have a portfolio of maybe that is a stocks portfolio with what? Which is in the markets. When you compare with another well performing stock, okay, the difference will be what? Will be very high. Okay, so that's why we usually talk about that is volatility. When we talk about volatility, it's either a high gain or a high loss. Okay, so you can gain much, you can gain that is you can if in case of a loss, then you will suffer a loss big time. Okay, so basically if you get a high variance between those stock portfolios, then you will know that your that is your stock, okay, will be what, will be highly volatile. Okay, and now with that you can now determine if you are a risk averse person, then you can now decline maybe investing in those stocks. If you have the risk appetite, then you can invest in those stocks. Okay, then when we talk about standard deviation, uh, we've seen it basically shows us the consistency, okay, in investments, in terms of investment returns. So if we usually say that if the variance is very high, then that is we can say the data is highly dispersed. Okay, the data points are far away from the what, from the mean. Okay, if the variance is what is if the variance is a small value, then the data is close to the what, to the mean, and we won't have outliers. Okay, we won't have many outliers. But if we have a high variance, then we might say that your data is having what, high outliers. Okay, all right. Yes, Brian.
How do you know? How do you know what when it is a high or a low variance?
The value itself will be, sorry.
As in, what number is high, what number is low?
Okay, so basically any value which is close to zero, okay, it is what, it's lower. Okay, it's like
Oh,
when we are talking about we shall discuss that when we are talking about covariance. Okay, like how do you determine the best covariance, because we know that is the covariance ranges between negative infinity to infinity. Like a covariance can be a negative 1 million, it can be also positive 1000. Okay, also when we come to standard error, okay, to determine which model like if you are given two different that is a standard error value, you know which, or you can know which that is which standard error, okay, shows a better what, a better model. So any value which is close to zero, okay, it is small value. Okay, so basically with that we'll have what, we have that is less variance. Okay, let's go to some takeaways. So variance is measurement of the spread between numbers in the dataset. Investors use variance to see how much risk an investment carries, okay, and whether it will be what, profitable. So variance is used to compare the relative performance of each asset in a portfolio to achieve what? The best asset allocation. Like for example, if we have different assets in your portfolio, if you try to compare maybe your what? That is the variance between a specific well-performing asset with another asset, okay, you can be able to do what, to do like a selection or an asset allocation. Okay, or you can now decide to what, to do what, to have to do what we call diversification. Okay, you can put in order that is to diversify your risk. Okay, like you can put well performing assets together which have that is a small value, that is a variance. Okay, then the other one you can also do what, you can also decide to have another portfolio for that is for high risk, or you can try to combine. You combine a high risk, that is a asset, with what, a low risk portfolio, so that in case of any loss, you don't suffer like big time. You are trying to avoid putting all your eggs in what, in one bucket. So in statistics, variance measures variability from the average or the mean. It is calculated by taking the difference between each number in the dataset and the mean, then squaring the difference to make them positive, and finally dividing the number of that is the sum of squares by the number of what, of values in the what, in the dataset. Okay. Yeah, so basically that's about variance. Okay, you can go and see maybe that is where do we apply variance. Okay, where can we apply variance? Okay, when you get a certain value of variance, what does it mean? Okay, so in that we shall check that when we will be doing what, when we will be doing practicals. Okay, I will have our data. We will that is calculate the standard deviation. We'll calculate the mean, and then do what? Explain what does this mean? What does this value of standard deviation or variance mean? Okay. All right. So I want us to conclude with a standard deviation. Okay, I want to take you through standard deviation so that next week we may discuss about covariance and what? Covariance and correlation. Okay, we shall see what is the difference between covariance and correlation. So basically, in fact, we've talked about standard deviation. We've said it's square root of what? Variance. Okay, and majorly we usually say it is it's majorly used to show that is the relative distance as well. Okay, so the standard deviation in statistics, we are saying it is a measure of dispersion of a data set relative to what? To its mean. And it's calculated by the square root of, as the square root of the variance. The standard deviation is calculated as the square root of variance by determining each data point's deviation relative to the what? To the mean. If the data points are further from the mean, there is a higher deviation. Remember that if the data points are far away from the mean, it means we'll have high deviation as well as high variance and high deviation. Okay, like the distance between those two data points will be what? Between the data points and the mean will be what? Will be very high. Okay, so if the data points are farther from the mean, there is a higher deviation within the data set. Thus, the more spread out the data, the higher the standard what? Deviation. Okay, so for standard deviation, we've said measures dispersion of the data set relative to its mean. It is calculated at the square root of variance. Okay, standard deviation in finance is often used as a measure of relative riskness of an asset. If that is the standard deviation is high, it's a higher value, then it means that is there is high risk in what, in your investment. So a volatile stock as what, as a high standard deviation, like a high risk stock or investment as what, high standard deviation. Okay, and as a downside, the standard deviation calculates all uncertainty or risks. Okay, so definitely when maybe you are calculating investment return and see the standard deviation is very small, then it means that that investment can give you what, can give you that is or it can be consistent in its returns. Okay. All right. So next week, Monday, we shall discuss about covariance and see what is covariance. Okay. What is the difference between covariance and the correlation? All right. Okay.